Okay, so let's take a look at our review for systems of equations. Question 1, what do we mean by a solution to a system of equations? So we're looking, when we talk about a solution, what we mean is a set of values that satisfy both equations or all the equations, meaning that they're equal to them. That when we plug the value of x in for y, or we plug the value of x in, it gives us the same value of y for each of the equations. And graphically, what that means is the point where the graphs intersect. All right, so a linear quadratic system may have how many solutions? So remember, when I'm talking about a linear quadratic system, that means a system of one linear equation or a line and then one quadratic equation that'll give us a parabola. So when we look at this, we have a line and a parabola, and they can intersect twice for two solutions. So two real solutions. They can touch for one real solution. Or they cannot intersect at all for no real solutions. All right, so a system of linear equations really should be 3 by 3. These are the ones we worked on all last week. Have what kinds of solutions? And we said when the bottom row, in the third row, if it's 0, 0, 1, and any number, then that's one real solution, our ordered triple. And we'll see those here in a second. If our third row comes up 0, 0, 0, 0, then we have infinite solutions. Meaning we just have any number we put in will satisfy our equations. Or not any number, but we have far more than one solutions. And then finally, if we have 0, 0, 0, 1 in our third row, we have no real solutions. Meaning our three equations do not intersect at any one point. All right, our three different methods for solving 3 by 3 systems of linear equations that we've went over so far are substitution, where we solved one equation for a variable, substituted that value, that expression in for that variable in the other two equations to eliminate it, and then continue the process with those two equations to solve for one of the two remaining variables and substitute that expression in so that we're down to one variable, which we can then solve, find its value, and backtrack from there. Then we had elimination, where we added the equations together to cancel out variables. And then finally, we had matrix operations, where we built our augmented matrix and used reduced row echelon form on the calculator to solve. All right, given the following information below, what is the solution for Z? Use a couple different color highlighters here. Let's start with pink. So So we see we have our x's in our first column. So our first column here, we see we have this 1. And so that tells us x is 1, x is 0. Then we have our y column. We have our y column. We see that 1 in the middle. That tells us this middle value, -2, is our y value. And then finally, we have our z column. We have our z column, and we have that 1 in the last position, and that's telling us that our z is this 2. So our solution is z equals 2, or z equals 2 if you're British. Okay, number 6. This says to graph and find the intersection. So we're going to do the calculator method for this one. So you see the second equation is already in a y equals form, so we need to get the first equation. So I'm going to take the -8x and the -16x and move them to the other side of the equation, which gives me y equals x squared plus 8x plus 16. So I added 8x to both sides to move it over, and I added 16 to both sides to move it over. And then my second equation was already in the proper form at y equals x plus 6. So we're going to go into the calculator in the y equals button and y1. And it does not matter which equation you put into y1, which equation you put into y2. And then we're going to hit second, trace, 5 to bring up our intersection tool. And then we're just going to find the intersections where these two intersect if they do. And they do. And we get -2, 4 and -5, -1. -1, +1. I think that's a +1. I'm going to say it's a +1. I think that's a typo on mine. Not 100% sure. Now let's see. -5 plus 6, 1. Yep, that's a typo. That should be a 1. All right, so that's how we do it graphically. Order triple using our matrix functions. The first thing we have to do when we're using our matrix functions, we have to ensure that we're in standard form. So x, y, z, we're in alphabetical order, and then our constants are all on one side, so we're good to go. So we need to write our matrix. So all we're going to do is we're going to take our coefficients. So anytime we don't have a coefficient, we have a 1. So there's 1x, 1y, 1z, 3, 2, -1, 2, 6, 3, 2, -1, 13. So we're going to go into the calculator and we're going to hit second math. And then we're going to cursor over to the second column to math, reduce row echelon form. And we're going to hit enter. That'll bring you back to the main screen and you'll have REF with the parentheses waiting for you. And then we're going to hit alpha. Tracer zoom. This should be zoom. And that's going to bring up our matrix form, and we want a 3 by 4. We're going to enter our matrix in, or once we do that, we'll have our matrix pop up on the calculator. We're going to enter our matrix in and hit enter, and you should get a solution matrix. Probably help if I write the matrix first and then draw. That says 1004, 0100, 001, -1. And so our ordered pair, our order triple here is 4, 0, -1. So x equals 4, y equals 0, z equals -1. And we're done. Now, number 8, be careful. Make sure you read what the question's asking for. It says write a system of equations that could be used to determine the revenue for each type of pizza. It's not asking us to solve, it's asking us to write the system. And the nice thing, when we have a table, we already have our matrix, which would have made solving easy, but we do not have any variables. Easy thing, and it makes sense to keep things simple, is we're just going to take the first letter for each of our pizzas. So our first equation, we have 12 cheese pizzas, we have 20 pepperoni, we have 8 sausage, and that's equal to $74. Our second equation, we have 15 cheese, we have 31 pepperoni, we have 12 sausage, and that equals $108.50. And then we have 9 cheese plus 13 pepperoni plus 5 sausage, and that equals $49.50. And that's all we have to do for this one, is write the system. We don't have to solve it. We don't have to find how many cheese pizzas, how many pepperoni, how many sausage. We just write the system. Pause for a second for station identification, and we'll move on to the back. All right, Jeremy buys 2 slices of pizza, X, a drink Y for $5.50. So like I said the other day, it will help us if we go ahead and write pizza, X, drink, Y. Think about this as like a legend on a map. So we have 2X plus Y equals $5.50. Now we have Macy buys 1 slice of pizza, a drink, and 3 cookies, Z. So we've got another variable, cookies, Z, for $6.50. So we have 1 slice of pizza, X. We have 1 drink, Y. We have 3 cookies, Z, and this equals $6.50. And then finally, a slice of pizza costs $1 more than a cookie. There's a couple of different ways we can write this one to start. We could simply say if we have a slice of pizza and we subtract the cost of a cookie, then we have $1.95 left over. And we're good. We don't have to solve this one, even though I did apparently on mine. That's all we have to do. Another way you could write this one to start is you have your pizza price is equal to your cookie price plus $1.95. And then when you subtract Z from both sides, it gets you to the first equation. All right. Next one, it says graph and find the intersection for number 10. So number 10, we're going to do the same way that we did on the front side. They're already set up. So we're just going to go back into y1, x squared minus 7, y2, 2x. Graph them, second trace intercept, find your intersections, and you should have negative 1.83, negative 3.66. And then your second one is 3.83, 7.66. All right. Number 11. Kelly has 39 quarters in her purse, only nickels, dimes, and quarters. She has 8 more quarters than nickels. She has a total of $6.50. How many nickels, quarters, and I didn't ask about dimes. Does she have? Now, we're told about what she has up here, and we're already given this system of equations here, but we're not told what the variables are. But it's pretty straightforward looking at this last one, that nickels are X, dimes are Y, and quarters are Z. So from here, since we are solving, we can go and write our matrix. So we have 1, 1, 1, 39. We need to rewrite this second equation. So we're going to subtract x from both sides. So this becomes negative x plus z equals 8. So we have negative 1, 0 because we have no y, 1 for z, 8. And then we have 0.05, 0.10, 0.25, 6.50. And there's our matrix. Again, calculator, reduce row echelon form. Follow those steps, and you will have those steps tomorrow. And we get a solution matrix of 1, 0, 0, 14, 0, 1, 0, 3, 0, 0, 1, 22. Now, if we look back over, question's only asking for nickels and quarters. So we're only looking for X and Z. So Kelly has 14 nickels and 22 quarters. And before I forget, you can check these because we look, nickels are X, quarters are Z. If we look over here to the second equation, X, so 14 plus 8 equals 22. 22, we're good. And you could run through a couple of other ones if you wanted to and make sure. Number 12, solve algebraically, think quadratic formula. So quadratic formula, we need to get rid of our y. So we're going to take this first equation and we're going to rewrite it as y equals x plus 2. And all I did was I added x to both sides, I added y to both sides. Now, since y equals negative 2, we can substitute out for this y right here. And we have x plus 2 equals x squared plus 4x plus 6. Subtract these from both sides, and we have 0 equals x squared plus 3x plus 4. Now, quadratic formula, negative b plus or minus the square root b squared minus 4ac, all of that over 2a. So I'm going to take my a, b, and c values from here, and I have negative 3 plus or minus the square root of 3 squared minus 4 times 4 times 1, all of that over 2 times 1. When we simplify this, we have negative 3 plus or minus the square root of negative 7 over 2. Now, negative 7 tells us no real solutions. And we are done. Last one, number 13. We've already got our system of equations. We're already in standard form. So all we have to do is build our equation, our matrix. And we have negative 2, 1, 6, 1, 3, 2, 5, 16, 7, 3, negative 4, 11. Then we do our matrix operations on the calculator. So second math to bring up matrices. Go to math, go to reduced row echelon form, the RREF. And then once that's in, hit enter. Then goes alpha zoom. That brings up your matrix chart. Do a 3x4. Plug this information in, hit enter, and you will get a solution matrix of 1, 0, 0, 4, 0, 1, 0, negative 3, 0, 0, 1, 2. And our ordered triple, 4, negative 3, 2. Remember that we would have X, let's do it for color. This is our X column, this is our Y column, this is our Z column, and this is our constants column. So since we have the 1 here, it comes across, that's how we know X is 4. We have the 1 here, we come across, that's how we know Y is negative 3. The 1 here we come across, and that's how we know Z is equal to 2. And ladies and gentlemen, that's it for the review.